Welcome back to Built to Ship, the podcast where we go behind the scenes with founders and product leaders shipping real AI products into the world. I'm your host, Tyler Postal from Voker, and today I'm excited to be joined by Julien, co-founder and CTO of Quintess AI, a platform that provides AI maintenance teammates that automate tedious tasks, integrate with existing ERP systems, and deliver real-time insights so your teams can keep assets running smoothly. Julien, it's great to have you here.
Thanks for having me, Tyler.
Of course. Well, why don't we start out a bit with your background and the founding story? What were you doing before Quintess, and how did you come up with the idea?
Yeah. So software engineering is my background in general. So I've been doing this for about 15 years now, mostly at B2B startups. So I've been working for the kind of topics I've been working on are optimization for fast fashion retail. I've been working on on a data platform as well for ESG data. But usually, like B2B and usually towards fairly large customers. And during this, I've been working a lot on integration to complicated legacy systems. It's always been a big pain point and usually the bottleneck whenever we needed to integrate. And I realized that one of the big problems is just that people don't have the time to switch over to any other system and they're pretty much stuck with it. And I've really seen pain from operational people just using them. So I don't know, people from accounting, back office, whatever. So there was always a reason why the system couldn't change and everybody got stuck with this unsatisfactory situation. And so basically I knew the pain point, and one day a good friend of mine from uni, actually, Zach, reached out and told me about an idea that maintenance technicians wouldn't have to necessarily keep interacting with these old systems. And I just loved the idea, and I jumped on board.
That's amazing. I always love when kind of old connections from whether it's uni or sometimes even earlier or previous jobs, when you find an opportunity to work together on a startup. That's really exciting. Tell me a bit more about, like you said, maintenance workers. Give a bit more sense for the audience. Who are the target users and customers of Quintess? Is this like everything from plumbers to electricians, or is it a specific segment?
Yeah. So really, so it's industrial maintenance. So usually, so it's technicians working on large, complicated assets. Right now, our main market is railroad, freight, passenger, essentially, anything that runs on rails, essentially. And so for you to picture a little bit is essentially technicians who know, who have deep knowledge about I don't know, a subway or a commuter train, and they have different they are organized in usually different shifts with the objective of fixing anything that needs to be fixed now to put the train back in service the next morning, or perform maintenance plans to just make sure it's preventive maintenance to make sure that nothing breaks and nothing catastrophic happens. And then you also have teams that just run modernization, more longer term improvements on the assets as well. And so all these people have to interact with a class of software that is called an EAM. It's essentially ERPs for maintenance. And so it's pretty much what you'd imagine, very complicated forms with maybe 5% of the fields that are actually used by the people, and the rest is just nonsense to them. And yeah, but they do have to get information from that system and push information back to that system after they finish their work. And we're here to bridge the gap essentially with yeah.
Very, very fascinating. Yeah, it sounds like one of those things where I don't even realize, or most people probably don't even realize how much time and how much effort goes into like just keeping the trains running, and then also to like even try anything that's an upgrade. And obviously, it's important that they probably go through very specific processes and document everything, but at the same time, that takes away from doing the actual work. So that's interesting, like kind of background work that's done that we probably don't think about, but is so critical for these services.
Yeah, it is, and it's actually very like skilled people. So most of them don't have an engineering background per se, but they really became experts at their craft essentially. And there is really this. It's crazy because like every time I go on site on a visit, I really see parallels with the software development
Mm.
people, and even in the way, because these guys, they're really good at troubleshooting, like the same way that we would approach, like, I don't know, a production outage. Like they're really, so they test hypotheses. Sometimes when there's something that is not too critical, they swap out like a part, send it back, and just see if the tram comes back the next day. Of course, you can do that with everything, but it's actually pretty complex stuff, and it's always a blast to just chat with them. And but the thing is, yeah, like they really love the systems that they operate on, but these systems are not software, and they want to spend as much time as possible on the trains and as little time as possible on the
Hmm.
computer.
That makes sense. Yeah. And to your point about the craft, I definitely, anytime I interact with anyone from like a mechanic to a plumber to an engineer, like you're talking about, they're working on these, trains or other sort of industrial. I've talked to folks who work like on roller coasters and things like that. It's amazing
Yeah,
how much creativity, how much resourcefulness, all that goes into the craft. And I think it's funny in AI, everyone's always talking about how it's going to disrupt every single market and every single job. These are positions that I feel are not going to be
oh yeah,
like that. There is so much knowledge, and even just like the fact that you have to work with your hands on a system. Um, I think those jobs are going to continue to be extremely important,
oh
for a
yeah,
long time.
oh
But
yeah,
at the same time, like you guys are, what's great is what you're doing is there's other parts of the job that they're not critical to, they're important, like, keeping track of everything, but it's not really their core skill set. And it's kind of in a way a waste of their time, and so that's a place where I can help, but it's not going to replace their ability to like fix the train.
yeah, exactly. And one point that, and this is why on-site visits are so important as well for us. Um, uh, like it was actually a fear, like a general fear that people have about AI, like I'm going to be replaced. Um, and in this case, it's clear. Like I mean, their jobs are safe. Like no doubt about that. They're just like what they do. I mean, the AI won't have their hands like deep into an engine or something. It's and and yeah. So we're really trying to. Um, uh, so so of course we're not replacing them, so we remove a part that could be considered paperwork, I guess. It's just like, yeah, reporting what they did. But so what we do, essentially, so we deploy voice agents for them, and usually the way they use us is through a phone call. So basically, and the reason why voice was so important in this case is that it's the really the lowest friction modality for these guys that usually have their hands occupied and dirty. So yeah, they have been through rounds and rounds of like SaaS companies trying to put like a tablet in their hands or anything. But like, I'm sorry, but I can't do anything with this. And so yeah, this is and they really see the value essentially. So part of it is reporting. But now more and more we're moving into bringing useful context to them. So essentially it can come from standard operating procedures, it can come from technical documentation, maintenance manual, parts catalogs. But sometimes when they're on the job, like maybe they spend like, I don't know, 5 hours on researching a fault, or just performing the 200 steps of a maintenance plan. Um, and more we're there for them as they're doing that job. So the idea is really that essentially they do all that stuff like for long periods of time, and we're just like with them on the mic and and earphones. Yeah.
That's great. No, I think the what you're kind of getting at, the modality of how to interact with AI is something that it's still really early for the industry. Early days, everyone's like, it's a chat interface and you should use that, and like, this is a really clear example of where it doesn't make sense. But there's even other cases where like, is chat the best way when you could just click a button and have the AI happen in the background? And so, yeah, very, very fascinating. What would you like, what are let's say list maybe anywhere from 1 to 3 AI features or products like that encompass what Quintess
Yeah.
does.
Yeah. So yeah, I'd say there is fault reporting in general. So creating new faults when you find them on a train, reporting work that you've been doing on a fault. So that was really our initial wedge product, let's say, because it was okay. So you know what, you won't have to go back to the computer every 30 minutes. You can just like do it all from where you are. And then like for the more advanced and more recently deployed features, we do interactive part search. So that's actually a pretty big one, because like these guys, depending on the job, like they have to go through a catalog, physical or virtual, of like several thousand parts. And usually it's pretty obscure. So it's like vendor specific references with obscure names. I was recently with a customer in Norway, and just because the constructor is German, like everything was in German. Like it's kind of hard to to go through, but they actually need to book the parts to keep the stock accurate, and for accounting reasons and everything. And so essentially, we realized that just helping them go through this catalog was key. So it turns out that this particular thing is usually done when their hands are not dirty. So this is something that we can do with a screen. So we essentially have a mobile app that just narrows down, based on the context we have, the few pages of their parts catalog that are relevant. And it was like, okay, so sounds like you were using, I don't know, such and such part. So is this A or B? And they're just like, yeah, it's B. Where before it might have taken them like 2 hours to actually find the right part at some point, and have to talk to a part specialist that actually knows how that stuff is laid out in the database and all this. So part search here would be the second one. And the one that we're currently working with is a troubleshooting copilot, essentially. So it's just walking the guy through essentially performing structured troubleshooting steps. So this one it's going very deep into their technical stuff. It's hard. It requires like a deep understanding on essentially the systems that they operate on. And yeah, so this is something that is under development, but we're seeing good first responses. And yeah, so lots
Very
of
cool.
RAG, lots of, as you can imagine. Yeah.
Yeah, well, no, this is fascinating. I love the like breadth of the types of problems you're solving here.
Yeah.
I kind of want to dig into the second one, the part search. We've had a bit of experience doing this with automotive industry or
Yep.
electronics components, and I think maybe this is a good opportunity to share with like our audience some of the pros and cons of LLMs, like what they're good at and what they're not, because everyone just talks about it as being magic. And so in some ways it's really valuable to have an LLM for search, because let's say two part names, you're kind of getting at this, but like the reference numbers or the names are slightly different, either because of language or because of like it's called rubber gasket here, but it's called, I don't know,
Yeah.
something else similar somewhere else. That's a place that LLMs can be useful. But then there's like a bunch of specs that are numbers and letters and, you know, reference IDs. And sure, LLMs can take a guess at it, but, you know, we've found that we've had some struggles if you just throw a vanilla LLM or agent straight at the problem. And so I'm curious what you guys have seen. What does your setup look like when it comes to this kind of like these search features? Any challenges you've experienced, any limitations or benefits that you could mention for LLMs for this kind of problem?
Yeah. So what we really so what we've seen is usually there is, so indeed, like there isn't much semantics in the catalogs themselves. It's as you say, it's like references, numbers. Sometimes they don't bother spelling out an entire word and an entire word. And for some reason, like 3 or 4 words are concatenated into only one. It's like I don't know, like it's really strange. So what we try to do is to because usually the only semantics is the structure of the catalog itself. So essentially, the best semantics we have are like the section names, because usually on trains, on trams, on subways, they do have big structured parts catalog for everything, and so our first layer of semantics is really like the structure of the documents. So this is something that, so going through that structure to extract like the tables and the diagrams that are relevant to actually doing the search, and gathering like where you are in the tree on the way is really our like main, let's say it's what structures then our search essentially.
If I
And
could
then
pause there,
yeah.
I just have a question. That's really fascinating. Is that so that sort of multi-level trees, how do you actually, is that like just, hey, this is how we're storing the data in a graph or in a database? Or is it you just hand that catalog to one agent, or there are multiple agents that have to deal with each level? Like, is there anything you can share? Because I think too many people talk,
Yeah.
and maybe this is a situation where this works, but a lot of people talk about AI as like, you write one prompt, you have one LLM call, and then it just magically gives you an answer. But a
Yeah.
lot of times, really well-tuned systems have maybe like, you know, one agent that does one part, and then you have a more traditional search for the next part.
Yes.
Yeah, maybe can you share, how that
Yeah,
works?
absolutely. So in our case, usually, so we have context on the faults, and this context can translate to a few pretty, I mean, a few candidates in terms of like where we are exactly on the system, and usually it narrows down things like a lot already. So we just have so we have pretty standard representations of like trees in our in our system. Like we don't need to do any kind of very complex traversal. It's really just uh, uh, so we have an agent that actually understands like the tree, and that is specialized in saying, okay, this is where we are in the tree, like, or this is where we might be, and so then after this is just usually it's just a semantic search over the sections of the catalog that correspond to these nodes essentially, or sometimes it's not even a node. I mean, sometimes it's not a leaf node, it's it's before that. But like, yeah, it's so we do have an agent that really like understands, okay, these guys, they've been working on like some specific part of the system, and we shouldn't look at anything else. So this is where we should look for our parts, for instance, in this case. So yeah, it's really and it's key for us as well to actually uh, like locate to get the proper location in the tree, but without becoming like these old clunky software again. So essentially, it's
Yeah.
not like so first level is X, second level is Y. What is third level? A, B, or C? We don't want to do that, of course,
Yeah.
but it's all contextual. But yeah.
So for these like tree of data, is that just stored in like, a traditional relational database or something like that? I assume it's not just like a blob of text that you hand to an
Yeah,
agent.
yeah, 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 yeah,
Yeah.
exactly. Yeah, essentially, it's a hierarchical structure usually. So yeah, we actually store it in a relational database because, I mean, it's like you only have so many categories in the end, and it's the tree itself is usually small enough to just be loaded in memory
Mm,
and then traversed. So we have mechanisms for. So the agent that try to find the category. It actually so it really uses the tree as a human would, like, but it just
mm,
does it, of course, with more context, and it can hold more things in its head at the same time. But it's really similar, like the way
mm.
we traverse and identify the candidate categories. It's really similar to what a human would do, really. Um, and yeah, so just an in-memory representation of the tree and the tools for the categorization agent to prune it, like depending on what it knows.
Mm.
And yeah, it's yeah,
That's a great example. I think, yeah, I appreciate you getting so in depth with it because I think again, there's a bit too much hype and oversimplification of, every single chat tool you or like AI tool you see today. It's like, ask me anything. It's like, that's not true. I'm sure you're not meant to be asked anything, right? Like in your case, they shouldn't be asking about, I don't know, calculus problems probably, right? Like it's
yeah,
solving a specific problem. And I love how you have this structured traditional, part of the architecture, which makes sense, is like you have this tree, it's stored in a relational database. You have an agent whose purpose is to find where in the tree should I be looking. It's not being asked to like, take the direct question and immediately just produce an answer. It's like, okay, we've thought about how to split up this problem. First step is figure out where the information should come from, by traversing this tree, pruning sections, and then deciding, okay, this is the context that's relevant to this query. And then I know I cut you off, but then what happens after that? So now agent one has figured out these are the whatever parts lists or the documentation that's relevant to this particular question. What happens next?
yeah. And so what happened next, like for this particular case, so we usually do have semantics about like the category tree itself, like because it's like the structure of the training. It's usually the things that are described fairly decently. And so then once you know where you are, you then have maybe like 150 parts that you can look through. And then, so depending on the level of of how opaque the references are, sometimes we have to so essentially, so there is a question how you represent uh, and store the information. So what we do there is really just a vector search. Like we have as rich representations as we can of each part. Sometimes it's given by the part catalog itself. It's self-sufficient in a way, and sometimes absolutely not. And we have to pair it up with other information, like a maintenance manual, for instance, that really describes uh, not in detail what it's composed of, but more what it's for and what are the important parts. And so there so yeah, the essentially we have a pre-processing agent, like that just does work in the background before that. So usually the good thing is that the maintenance manual have a similar structure to the parts catalog as well. And so essentially it's just okay. So you model, you just have to understand like this section of this maintenance catalog very well, and then you have these parts. and so you have to make sense of these parts given the context of what this subassembly is for, and how it's used. And usually it works out pretty well. Also, it turns out that maybe like out of 25 like 25 30,000 parts, usually only, I don't know, maybe 10% of this is actually used regularly and booked regularly. So
Mm.
that's information we use as well. Like we know that some of that stuff is actually not relevant, and that's just simply by like they all have just tables with the parts that are actually bookable in their system. So that's a big filter as well. Um, but like yeah, essentially understanding where you are, having as good of a semantic representation of the parts as you can, uh, and in some cases showing the picture, the technical diagram if we have it, and being like, okay, it looks like call out 4, is that the right one? Yes, and then and then we move forward. Yeah.
Amazing. And so that last step, just so I can understand it, is you've now selected, let's say maybe you've used some of the manual because the parts reference is missing information. The agent, pulls out either one or maybe multiple parts to recommend. And then does that show up in like a chat interface for the user to say yes or no to, or what's that final step that the user sees?
Yeah. So this visual aid is essentially so we're developing and starting to roll out a mobile app for our customers, and it's so basically it's just visuals that we give them. So the idea is really that voice is the primary mode of interaction still, because most of the time they don't even, like, they don't want and they can't look at their screen.
Yeah.
And so but for this, for instance, for like part search, like they
Mm-hmm.
have to, because it's something that they have to do it. Um, I mean, they have to look up a number somehow. They must have like maybe the broken part that physically must be
Mm-hmm.
replaced. They have it, and so this is a time where we actually have more of their attention, and so we can afford to bother them with a couple of technical diagrams.
Yeah, and it's
Yeah.
probably useful to have an image in that case. Like you don't just want to be talking to a voice and be like, it selected this part, and you're like, well, I have to visually compare, is the part in my hand the same one that it's showing me? So again, it sounds like you guys are putting a lot of thought into like what's the right modality to deliver this AI experience in, depending on where the user's at, which is great. It takes, I think, being thoughtful about a product and not just saying that, oh, the AI is just going to solve it all on its own with no other systems or no other visual aid is
Yeah.
a little bit of a far-fetched claim. Okay, I could keep talking with you forever. I know we're at time, but before we start to wrap up, I just wanted to ask a question we like to ask a lot of folks who are, there's a lot of people still building AI features that aren't in production yet. Since you guys actually have experience with this, you have customers in production, users trying out the product. How are you keeping track of how well the agent's working? Is it mostly users telling you anecdotes and screenshots? Do you have a way to, look through recordings or logs? Do you have an analytics tool? What do you do to monitor your agent performance in production?
Yeah. So there is the systematic part, let's say, like we really try to capture like every single bit of information that we can, and that our customers will let us keep as well. So that includes audio recordings, transcripts, of course, like full execution traces for the LLMs. Like we have like trace records for every single phase of every single conversation. So yeah, we really we have to have all this data for troubleshooting and analytics. But of course, like it's when you have to go deep. Then we use a couple of observability platforms. Actually, we have several ones hooked up to our system. So mostly Langsmith and Logfire that we use quite a bit for. Like again, it's really for observability. Um, and then so we use Koval as well for
Nice. They're from our batch at YC.
Oh yeah,
Works,
right,
works
yeah.
great. Yeah.
Yeah. It's a great product, and we use it almost. So now we're really starting to use it as a almost. If you transfer this to traditional software, like almost test-driven development, if you will. Like of course it's not like entirely the case, but for regression testing, it's really great. It really forces you as well to kind of anchor what you do in like actual cases, and sometimes if the simulated user gets tripped up, maybe it's that you're actually doing something wrong. So it's always good to know. And then another thing that we do is trying to keep as direct a line as we can with not only the managers and the people who decide whether the techs will use the tool or not, but with the techs themselves. Like they're usually super skilled, and their time is critical. They're like and the power dynamics are interesting actually between the techs and the managers, because there are essential people, like essential workers. So you can't just like push a product on them and be like, oh yeah, use that. So these guys, like, they're worth a lot to their organization and their knowledge, and so we really want to make sure that we're actually helping them. And part of this is making sure that we can get direct feedback from them if anything goes wrong, and that we can fix it. So that's the more human side of observability.
Amazing. Yeah. Thanks for sharing all that. And we'll definitely have to have you on in a future season of the pod, because I think there's a lot more we could dive into. But thanks for going, so deep into like everything that you guys have built, and sharing your experience with the audience. As we wrap up, I want to put your website up on the screen.
Okay.
Quintess.ai. Please share with everyone who should try it out. How do they get in contact? How do they follow along with what you're building?
Yeah. So essentially, so I'm usually buried deep into my code. So the person that is actually most active on LinkedIn, especially, is Zach, my co-founder. So essentially, if you have a maintenance operation, and the problem that we talked about before resonates with you, you should reach out to him. So on either on LinkedIn or Zach at Quintess.ai, and we'll love to chat with you.
Amazing. Thanks everyone for listening in. Julien, thank you for sharing so much about what you all have built. And I love, again, the approach to really thinking about the actual end user, actually going out to sites and thinking, oh, their hands are dirty, they're not going to use an app. I think this is a good reminder for everyone building AI systems to put yourself in the shoes of your user. Make sure you build something that isn't just exciting technologically, but also fits what the user's pain is. Appreciate you sharing all your time, Julien. And for everyone listening in, if you're building something, go ship it. See you next time.
Thanks.